Okay, so in this next lecture, we're going to talk about DTensor operations. So here, we just do a very simple operation of a matmul. So we've done a couple things. So we've made it a square tensor just to make things easier. So now we have a 2 by 2 tensor. We're going to distribute it on the first dimension. So we're going to shard by columns. We're going to call this function, and then we're going to print out what what x looks like after this. So if we run this, you'll see that it runs, and what's interesting is that it gets printed twice, right? Because we have two ranks. The output tensor x is also sharded on dim1, and if we come take a look at the TL parse, you can see some interesting things. So here we are getting a shard of x, and what we're doing here is we're doing all gather. So you can see that under the hood, DTensor has decided, hey, to do this matrix multiplication, we need to reconstruct x into the full x. And then what we're going to do is we're going to do a matmul between this all gathered x and then the shard of x. And to make this more clear, this is effectively what's happening, where we are sharding it on columns, and then DTensor under the hood has algorithmically figured out, okay, to do this matmul, we need to materialize all of x, and then we're gonna matmul it with a column shard of x, and then we'll nicely get this new DTensor that just sharded already after this matmul. And you can see, unlike the previous lecture, these two graphs are the exact same. And the reason is because the input is already sharded. There's no redistribution here. So yeah, that's a quick high-level overview of the matmuls. And hopefully you can start to see the magic behind DTensors, where as a user, you just have these DTensors, you just call operations. But under the hood, DTensor is actually doing some clever things. It's figuring out how to redistribute tensors to do operations in the most efficient way.